Okay, so how do you think you could solve that?
Would you subtract 12?
Well, if I subtracted 12, what would the next step be? Like, can I combine these two things?
Yes. No. No.
I could if I was multiplying. You're right, because if I had the same base of e and I was multiplying, then I could add exponents. Do you see a pattern there by any chance whatsoever?
Oh, it's
Is it a quadratic by chance? Maybe? Okay, so let me show you a little thing we're going to do. We're going to use basically like substitution. We're going to say let n equal e to the x. Now, when I do that, I see e to the x squared. So let me write it like this, e to the x, there's my n squared. Okay, so that would be n squared. So I'm going to write it as n squared. I just want to show you what I'm doing for that. And then I'd have minus 7n plus 12 equals 0. So do I have a quadratic? I absolutely do. You're going to have to see one all the way through before you're going to know what to do with these. But what can I do now? Can I factor it? Okay, how would that factor? Yes, but they both have to be negative. So n minus 4, n minus 3. And then to solve for these, wouldn't I say n minus 4 equals 0? Using the zero product property, and n minus 3 equals 0. And at this point, I'm going to substitute back in. So substitute back, and I'm going to take my n's and I'm going to replace them with e to the x. So I'm going to substitute back in e to the x. So I have e to the x minus 4 equals 0, e to the x minus 3 equals 0. Now, is this something I can now solve since I know logs? It is. So what would I do? I'd add 4. I get e to the x is equal to 4. And I would do what to solve for that exponent? Take the natural log of both sides. So natural log here, natural log there. And the x is a power. So I'm going to bring it down front. So I end up with x is equal to ln of 4, which you can just find in the calculator if you have your calculator. And then on this side, I would have e to the x is equal to 3. Again, take the natural log. So I end up with x is equal to the natural log of 3. So basically I have two solutions. Now, if you have a calculator, you just plug that in your calculator. But you're going to simplify it all the way down and get it in exact form. Okay? So that wasn't too bad, was it? Okay, let's do another one. So this one doesn't have a base of e, but it still is going to be the same kind of concept. This is a little bit more challenging, though, with the rewrite. So I have 2 to the 2x plus 1, and then I have minus 7 times 2 to the x equals 4. Okay? I want you to think about it. What could you do with that? So how many of you think you may know what to substitute with? Anybody have any ideas? What about 2 to the x? Now, it's sort of like a hint here. So do you see I have minus 7 and then I have 2 to the x? So wouldn't that be kind of like minus 7n? Okay, so let's do n is equal to 2 to the x this time. Now, I'm sure this is what's confusing you right there, isn't it? Could that possibly have a Lie coefficient? Could that be what's going on? Do you see a 2 to the x here?
Yeah.
And then, but then there's also a 2. So it could it be 2 to the x squared? Any ideas about how to break this apart? We talked about it just a minute ago. When you multiply powers, you add exponents. So could I break this apart as 2 to the 2x times 2 to the 1? See what I did? So if you were multiplying that together, your base is a 2. It looks weird because it's not a base like an x or whatever, a q or whatever. It's a number. Your base is a 2. And if I'm multiplying them, you would write the base of 2 and you would add the exponent. So I just broke it apart, didn't I? 2 to the first is just the number 2. 2 is my coefficient. This 2 is my coefficient. And then guess what I can do with this? 2 to the x squared. So 2 to the x squared, just like we did on the last problem. So could I do n squared here? So this 2 right here is this same 2 that I have as a coefficient. And then I'll just kind of show you how to rewrite this. So it'd be 2 to the x squared. Isn't that really 2 raised to the 2x? So I'm going to replace this 2 to the x with n. So it's n squared minus 7n. And then I would want to, of course, subtract the 4 over like this. So whenever you see something kind of weird like that, for the 2 raised to the 2x plus 1, you know your lead term probably has some sort of coefficient. So you're going to have to figure that out. And like I said, this is a really good way to see what you should be substituting with. Okay? Yes?
Why isn't it just n squared rather than 2n squared? Because it's like 2 to the x squared, and n is 2 to the x.
Because I'm making n, I'm replacing that with 2 to the x. So you're right, it is 2 to the x, but all of this gets replaced with n. So it's n squared.
Well, why is there the 2? That's what I'm asking. Why is the 2 n squared?
Why is the 2n?
Why is it like the coefficient in front of the n squared 2?
It's this. So that
Oh, okay.
that's that value right there. Yeah. Okay, good question. All right, so what would I do with this? Would this factor? Yes. Well, let's see. Do we know if it would factor? So do you remember how to quickly check and see if something factors? You do your a times your c, and you think negative 8, 2 times negative 4 is negative 8. Are there factors of negative 8 that add to negative 7? Yeah. So it's got a factor. I don't want you doing the term splitting. We're going to trial and error it just like we did. So this is going to be 2n, and this is going to be n, and we just have to play around with the other two. So I need a positive and I need a negative. So what if I made this minus 4? So when I do my outer terms, I get minus 8 plus n. There's my inner term plus 1n. So I get a negative 7n. And then I would set each of these equal to 0 to solve. And I would substitute back in. So I have to come back to this and substitute in. I could go ahead and solve for this. I'll show you a kind of different approach. So n is negative 1/2 and n is 4. And so could I right now just say n is 2 to the x and then 2 to the x? Now, how would I solve these? Same thing. I would do what? Use the log. Take the log of both sides or the ln of both sides. Okay. Now, when I try to do this one on the left side, what do you notice? I would take the log here or ln, it doesn't matter, and when I do this, it's invalid. This is not one of my solutions. This is not a solution because I cannot take the log of a negative. So that's how I know that's not a solution. This one is a solution. So then I would take the log or ln of both sides. And I don't really even need to do that for this one, do I? You can see 2 to what power is 4. Yeah, but if it was something you didn't know off the top of your head, like 2 to some power is 5, something like that, then you would have to take the log to solve. So that is your only answer. This was an extraneous solution because you cannot take the log of a negative. In other words, you can't raise 2 to some power, so 2 to the x. I'm never going to get a negative, am I? There's no way to accomplish that. I could get the 1/2, but it can't be negative. That's not going to happen. All right, let's do another one. This one. That one. Okay, this one I think will be pretty easy for you. This is example 3. So I have e to the 2x plus 2 e to the x minus 15 equals 0. That one you can do on your own. Okay, so take 1 minute, try it on your own. So what are you going to substitute with? N is going to be e to the x, correct? So then I have n squared plus 2n minus 15. This is going to factor. So I'm going to factor it as n plus 5, n minus 3. So here I get n as a negative 5. Here I get n as a positive 3. Guess what? This is not a solution. There's no way for e to be raised to a power to give me a negative 5. But here, e to the x is equal to 3. I'm going to have to use logs to solve this one. ln here, x, which comes down front, is just going to be ln of 3. And that's your answer. Okay? Let's do another one. Okay, how about e to the 2x minus 5e to the x, and then I have plus 2 is equal to 0. And I'm going to replace n, or substitute n for what? E to the x. Very good. So I'm going to have n squared minus 5n plus 2 equals 0. Guess what? Doesn't factor. So I've got to use a quadratic formula. So x will be equal to a negative 5 is a positive 5, plus and minus. Then I have b squared, 25 minus 4 times a times c. All that's over 2a, which is just 2. So this is going to be 5 plus and minus, and then I have 25 minus 8, which is going to be the square root of 17, does not simplify, all over 2. Okay, so I need to, I remember that, and look what I did. It's n. So n, and you understand why we're using n, it's because we actually are going to come back with an e to the x. It just gets confusing if you're replacing e to the x with x. That doesn't make any sense. So we're choosing n. So isn't this equal to e to the x? So how would I solve this? This is what I've got to solve. And let me ask you this. The square root of 17, if I was doing this without the calculator, the square root of 17 is what? A little bit bigger than what? 4. It's definitely not as big as 5. So guess what? Both of these are going to work, the plus and the minus, because I'm subtracting something smaller than 5. So it's going to be a positive in the numerator there. So how am I going to solve for this one? I'm just going to use ln. So I'm going to ln on both sides. And this will come down front, of course. So the left side, ln of 5 plus and minus the square root of 17 all over 2. That is equal to your x. And you do need to make sure that they both will work, and they both do work. Do y'all understand what I mean when I say they both have to work? Okay. So you can't just ignore an answer because it has the subtraction in it. You need to make sure and find out if is it a positive or is it a negative.